Hello, everyone, and welcome to today's webinar on safeguarding public assets with high frequency planet SkySat imagery using AI and ML. My name is Pritish Bisoy. I am Sales Director Planet for India and South Asian countries, and I will be moderating this session today. In this webinar, we are going to present how Odisha Space Application Center, ORSAC, together with Vassar Labs, leveraged Planet's high-frequency, high-resolution SkySat imagery to monitor unauthorized land use changes and encroachments in Bhubaneshwar, the capital city of Odisha state in India. Before we start the session, let me introduce our respected panel of speakers. We are honored to have with us Mr. Prafulla Kumar Malik, an IFS officer and the Chief Executive of Orissa Space Application Center. Orissa Space Application Center is the apex body of the state of Orissa for space technology applications. This center is equipped with sophisticated GIS and computer labs with latest GIS and image processing software. It has a team of well-experienced multidisciplinary application scientists to undertake remote sensing and geospatial technology projects. Mr. Malik could not join us physically because of some last-minute meetings, but he has shared his comments and a video is available with us, which we'll be playing during the course of this webinar with Mr. Malik's message on this uh, how he and his team at ORSAC used planet imagery along with AI and ML technology. Then we have Mr. Lakshmi Prasad, co-founder and CEO of Vassar Labs. Lakshmi Prasad is a serial successful tech entrepreneur. He has a bachelor's degree from the Indian Institute of Technology Madras and a post-graduation from MIT, Boston. His organization, Vassar Labs, pioneers in IoT, machine learning, and artificial intelligence-based solution development and integration with geospatial decision support systems. Next, we have Mr. Mahesh Reddy, who is the Director, Thiama Technologies, an experienced photogrammetrist and geospatial professional. Thiama is a marketing partner of Planet in this region. Next, we have my colleague Partho Ghosh, who is Pre-Sales Director Planet for the Asia Pacific region. With this, let's move on to today's agenda. My colleague Partho Ghosh will provide a brief introduction about Planet and an overview on SkySat imagery, followed by Mr. Prasad from Vassar Labs talking about the problem statement and how his team, along with ORSAC, leveraged SkySat imagery and AI/ML technology to address some real-world challenges. Then we will do a deep dive into the Bhubaneshwar Land Use Intelligence System, BLUIS, and finally have a Q&A. We really want to make this session very interactive. So our audience, please feel free to put your questions in the panel on the right-hand side of your screen, and we will go through them during the Q&A. Also, we will have 3 audience polls during the webinar, and I encourage all of you to take part in them. With this, now I am handing it over to Partho Ghosh to talk about Planet and SkySat imagery. Over to you, Partho.
Thanks, Pritish. Let me start with brief introduction about Planet. Planet is an aerospace company which builds, launch, operate, and maintain the industry-leading satellite constellation to make informed and timely decisions. We are mission-driven organization, and our mission has remained same since Planet was founded in 2010. And the mission is to image the entire world every day and make the information visible, accessible, and actionable to anyone. In the next, we will see what are the challenges in the traditional satellites we are seeing. At Planet, we are working with more than 40 industry with various domains. And across the industry, across the domains, we found various challenges in the traditional satellite and tasking workflows challenges also. So today's organization needs the real-time or near real-time understanding about their assets. Particularly in light of COVID-19, the traditional surveying and analysis methods are not feasible. And the traditional satellite tasking model is not equipped to deliver high resolution imagery efficiently. So inaccurate and outdated data may lead to lack of insight, inaction, and ultimately uninformed decision. Let's move to see how Planet is differ from others and how it will beneficial to the user. At Planet, we can capture the imagery daily or sub-daily basis. Users will get the freshest data to ensure confident, accurate decision making. Our satellites are capable to give you the complete coverage, not fragmented coverage in a specific time of interest, in a specific area of interest. We can offer you the complete coverage. We maintain end-to-end transparency in tasking workflow. We have our tasking API, and our user can take part in the tasking workflow by their own. So they can put their tasking order by their own, they can see what is the status, and once it is fulfilled, they can download it also. So that way we maintain the transparency. In the next slide, we'll see how our constellation runs. This is a small graphical video, and as you know, we have more than 120 PlanetScope satellite, and using this PlanetScope satellite, we are capturing the whole Earth's surface every day. At the same time, we have 15 number of SkySat satellite which are running in the sun synchronous orbit. And using this SkySat, we can capture the imagery daily and sub-daily basis. With 6 more satellites on the equatorial orbit, we will achieve up to 14 revisit per day. 3 satellites on the equatorial orbit has already been launched and 3 is planned soon. So that way we'll achieve 14 revisit per day. Let's move to see some basic specification about our SkySat satellite. At this point of time, we have 18 SkySat satellite is on orbit, and we offer 50 centimeter orthorectified SkySat imagery. Here I'd like to mention one thing, that is, in the traditional satellite, the resolution difference between panchromatic and multispectral imagery is 3 to 4 times. Means if the resolution of the pan image is 1 meter, the resolution of the multispectral will be 4 meters. So that kind of differences are there. But in Planet, we capture the multispectral imagery also in sub-meter resolution and deliver orthorectified multispectral in 50 centimeter. Means our user will get more spatial data, which is very much useful specifically for digital interpretation in the AIML platform. Our revisit may be sub-daily, maybe daily, weekly, monthly. That is on the basis of the user demand and on the basis of the feasibility study. We have 5 band in SkySat: red, green, blue, near infrared, and panchromatic. We'll move to the next part of the webinar. Before that, I'll back to Pritish for the first poll. Pritish.
Thank you, Partho. And audience, I'm going to launch the first poll question of today. So please select one of these 4 options. Which industry requires high resolution, high frequency satellite imagery the most? Is it agriculture, urban, energy and infrastructure, forestry, and land use? So while we get the opinion from our audience, Prasad, you and Vassar team have worked on multidisciplinary applications. Which industry do you think gets the maximum out of high resolution, high frequency satellite imagery? Prasad, yeah, you there?
Pradesh, can you hear me? Yeah. So thanks for the
Yeah.
question, Pradesh. All these 4 use cases are interesting. We see all these 4 quite often, but we see agriculture coming more and more often in our customer base.
Okay. Thanks, Prasad. Can we have the results of our opinion poll? Okay, that looks great. The audience says urban is about
Okay.
50%, and then followed by forest land use, and then agriculture, energy, and infrastructure. Thank you. Thanks for participating in this poll. And now let's move on to the remaining part of our presentation. Partho, over to you for showing some sample SkySat imagery.
Thanks, Pritish. We have seen the basic specification of SkySat. We have seen how Planet products differs from others. And next we will see some sample imagery of SkySat. We'll move to some location in Bhubaneshwar. And here you can see this is the imagery we have captured in May, 9th May specifically. This is 80 centimeter imagery captured on May. Let's zoom one more level so that we can view some more details. And here in zoomed view, I would like to highlight that the office premises of Orissa Space Application Center is visible in the center, and the complete spatial details of the ORSAC is visible here. So that way we can see. So you can see complete details, the ORSAC building and garden in the back side, in the front side, everything's are visible here. Next, we will move to some other location of Bhubaneswar. Here, we would like to mention that recently we have launched our 50 centimeter SkySat imagery, and this 50 centimeter SkySat imagery captured last week over All India Institute of Medical Science, Bhubaneswar. So let's zoom one more level so that we can see some more details about the imagery. So this is All India Institute of Medical Science, Bhubaneswar, and we can see how the spatial details are prominently visible here. It is slightly off nadir image, so that's why we are getting the side view also. And the next we will move to some other location of Bhubaneswar, and this is also 50 centimeter imagery of Bhubaneswar area, and this is one of the tallest high-rise building in Bhubaneswar. We can see clearly the how the area is visible, buildings as well as the swimming pools are also visible. Let's move to see some use cases related to urban. Here in this section, we'll see how we can monitor the public asset using high frequency SkySat data. Let's move to some area of in Bhubaneswar only. Here, this is 80 centimeter SkySat imagery of February. In the next slide, we can see the SkySat imagery of the same area where we can visualize the changes. So before imagery, in the we can see before imagery and after imagery, and we can see how the differences, how the changes has happened in just only in 18 days. In the middle, we can see the blue object has been moved from one area to another. In the upper left corner, we can see some playgrounds is there, that is also has been changed. Let's move another part. So here I would like to, I'm very happy to inform you that we are the imagery partner of Orissa Space Application Center for Bluis project, and we are offering SkySat monthly monitoring for Bluis, and we are capturing SkySat imagery for whole Bhubaneswar area every month. In this graphics, you can see an area of Bhubaneswar and how the transition of land use has happened in last 8 months only. In the top left, you can see there is a December 2019 image, and we can see a vacant land in the center, and we can see how the vacant land is changing on monthly basis till July 2020. Now we'll go next to see why SkySat is relevant. SkySat has many specialties. First one is the low latency. We capture the imagery by around 10:30 in the morning pass and 1:30 in the afternoon pass. And within 8 hours, we can make the data available for the user. This kind of low latency is very critical in monitoring part, and we are offering that. Our data is sub-daily revisit. We has morning pass as well as afternoon pass. We may opt for sub-daily monitoring. This is also very effective to get the cloud free data. In the morning there may be some cloud and afternoon may not be, so that way it is very effective. And definitely we are affordable if we compare with the other satellite products. We have various unique capabilities, not only the mono imagery, we capture the stereo imagery, and we capture the video, SkySat video from the sky. And ease of use, our order management or tasking is completely automated, where user will put tasking order by their own, see the status of the tasking, and once it is fulfilled, user can download also. That way it is easy. Our data is available in the GeoTIFF format, so directly it can be acceptable by any GIS or remote sensing platform for further. In the next part of the webinar, we'll see how ORSAC is using SkySat imagery in their AI and ML platform for automatic change detection and sending alerts to the stakeholder. Before that, I would like to back to Pritish for second poll. Pritish.
Thank you, Partha. Now I'm going to launch the second poll question for our audience. So here is the question. What is the most suitable frequency for high resolution satellite imagery based on urban land use monitoring? Is it weekly, fortnightly, monthly, or quarterly? So while we get answers from our audience, Mahesh, you have worked on many urban and municipality geospatial projects. What's your take on this?
Hey, good morning, everyone. I think for any kind of urban change detection or any land use kind of monitoring projects, we would definitely recommend a monthly frequency of data capture. Even if you take the case of Bluish project, which you're going to see now, the government of Odisha has actually opted for a monthly frequency of SkySat high resolution data. But if there is any other use case where changes or analysis is time critical, or the area of interest is smaller in sizes, one can definitely go for a weekly or fortnightly imagery. And it is technically possible, as Partha showed you. We have right now 18 SkySat satellites in orbit, and Planet can capture imagery at 50 centimeters at these weekly or fortnightly frequencies. Pratish.
Thank you, Mahesh. Can we have the poll results, please? Okay, I think we have a mixed answer. Most of our audience thinks it's going to be monthly, like we have delivered for the Bluish project, but 33% of our audience also feel that weekly cadence is also critical for urban monitoring. Okay, thank you. Let's move on to the second part of our webinar. So now I'm going to hand it over to Prasad. Before we get into the second part of this webinar, I would like to kind of highlight here that we all know necessity is the mother of invention. That means when we have a problem, it encourages creative efforts to meet the need or solve the problem. And actually, this is very apt in the context of Bluish as well. So now let's hear it from Prasad, how they kind of solved some real world challenges using high resolution planet imagery with AI ML technology. We will also hear the message that we have recorded from Mr. Malik, Chief Executive of ORSAC, in this part of our webinar. Over to you, Prasad.
Thanks, Pradesh. First of all, good morning, everybody, and it's my pleasure to share the work we're doing on land use monitoring using high-resolution satellite imagery and AI and ML. As you know, India and most emerging markets, right, we are seeing rapid urbanization, and this urbanization brings several challenges along with it. And few of the challenges that authorities face on a daily basis in the urban local areas are: one, the land typically is earmarked for a certain type of activity. It could be a park, it could be a water body, it could be for some other purpose. But because of this rapid urbanization, what happens is some of these lands earmarked for specific purpose may be used without any authorization for some other purpose. They may be occupied and used for some other purposes. Second, there may be buildings that may come up without any prior permission. So why is this difficult? Why is this important for the government to solve? One, because you're earmarking the land for a specific purpose. If somebody else is using it for a different purpose, now you lose the capability for planned development. Second, if somebody builds a building without a prior permission, that's actually a significant loss of revenue for the government, both from giving a permission to build a building or tax collection that comes out of giving a permission and building a building, right? So basically there is a issue of both revenue impact as well as planned development impact that this encroachments or unauthorized changes pose for the government, right? Moving on.
Good morning, everybody. Thank you very much to me an opportunity for this webinar of protection of the government land using satellite imagery, and particularly Planet Lab imagery, which we receive on monthly basis. And thanks to the Vassar Lab team who have designed the technical solution or the technical architecture for the entire project. We sincerely believe that a high value government land of a city like say capital city of Bhubaneshwar is to be protected using satellite imagery, and each stakeholder to be involved in this entire project. So basically we have three sort of stakeholders. One is the administration, other is the people, and our stakeholder is the technology environment. And using AI ML, Vassar Lab and our people, they are processing it. And using the mobile platform, the alerts are being sent to the concerned ward officer, like jurisdiction wise, and this is being attended to. One of the biggest challenge which you will be facing, like in the monsoon season, like we know that optical images are blind to cloud. So also we are planning to have a SAR integration, like microwave data integration to this project, and for which our technology partner Vassar Lab is working.
What is the thing that is driving? What is the motivation?
We are very thankful to my government. My government has initiated an initiative called the 5T initiative. That is technology, teamwork, transparency, then timely transformation. So in this 3T, this is involved with a program called Mo Sarkar, this my government. And this is a project of GAD department, who are the owner of the land of Bhubaneshwar, and these lands are managed by the Bhubaneshwar Development Authority and Bhubaneshwar Municipal Corporation. And to address the unauthorized activities in a timely manner, so that Bhubaneshwar city remains beautiful, planned, and is citizen friendly. Even the citizens are also involved in this project. Without our government blessings or support, simply this is not possible. The entire credit goes to our Chief Minister, beloved Chief Minister Sri Naveen Patnaik ji, and to our Secretary, GS Secretary C. Sanjeev Chopra, and also the BMC Chairman, and everyone in the government, and also team of my scientists who have worked hard, and my technology partner Vassar Lab, and a special thanks to Mr. Lakshmi Prasad, who is my alumnus also, and from IIT Madras, and a distinguished scholar from MIT.
So what are some of the steps that ORSAC, you and the GA department have taken to ensure that the technology is put to good use?
Yeah, this is a lot of hand-holding is being taken place. Like we have provided the technological support at the department level, at the user level. A lot of training program we conduct, and this is a continuous operation. Like we have a WhatsApp group, we have a webinar, we have a physical training to the people, and this is on the mobile platform. So the administrators, they know that what is happening to their alerts. And every citizen also, he knows, suppose he has given an alert regarding unauthorized activity on the government land, he knows where it is, what is the status.
So when we take on a technology initiative, sir, typically the first question that gets asked of any department is what is the value of the solution, right? How much value do you think the department would have got by implementing a system like this?
See, like this, if you roughly you can say 1 acre land will be costing around 20 crore rupees.
Yep.
In Bhubaneshwar.
It's about $3 million.
Yeah, $3 million. And the entire TCO of this project per year, max to max, will be spending around 1.5 crore.
Yeah. So the 1.5 crore is about $200,000.
Yeah. So this is the value. You know that and we are dealing with an AOI of 250 square kilometer, and it's quite a huge monetization.
So one alert could basically deliver the full value.
Yeah, full value.
Right. Already 10 alerts have been resolved, 10 or 11 alerts have been resolved. That itself can show the ROI, in terms of how this technology can actually add to the government function. Yeah.
This is the first kind of project in my state in which that AI and ML on the GIS platform is being taken. And I am really thankful to the technological architect who have developed this, and the Planet Lab people who have taken lots of initiative to give us the imagery, and thanks to Mr. Mahesh and thanks to Mr. Pritesh, who are very crucial in this project, and a big thanks to NRSC also, if we can share this webinar to them, where our government is very, very thankful to NRSC for the timely delivery of the Planet Lab imagery.
Yeah, thank you. So to solve the problem of land use change, we, as Dr. Malik has outlined, we developed a system called Bhubaneshwar Land Use Intelligence System, or BLUIS. It has primarily two parts. First part is how to identify a land use change and raise an alert. That's the first part. Second part is, once alert is raised, how to take the alert to its logical conclusion through a structured workflow and an IT system. Right? On the first part, BLUIS enables the government officials to identify any unauthorized changes in the government lands through three different means. First one is leveraging high resolution satellite imagery and putting them through a AI and ML algorithm to identify changes. Second one is through crowdsourcing, where we actually want to engage a citizen in the process so that they also feel empowered in the overall challenge, solving the challenge. So citizen, through a simple mobile app, can report a unauthorized change that they feel should not have happened in the Bhubaneshwar area. Third is also a department official can themselves report a change through the mobile app. So there are three things. One is satellite imagery with AI ML. Second is crowdsourced through a citizen. Third is crowdsourced through department officials. Once alert is raised by any of these three means, the alerts are triaged and sent to the concerned ward officer based on their jurisdiction for validation and evidence collection. So there is a standard operating procedure established. We'll talk about that in the next few slides by the department, with a predefined SLA to ensure the alerts raised are acted and resolved in a timely manner. To ensure that everybody is doing their job, we have developed user-specific dashboards to give visibility on the alerts, their status, the SLAs, and escalation process. So raising alerts, a mobile workflow to ensure the alerts are acted upon and evidence is collected and validated. Third thing is a visibility system to ensure that this is taken to its logical conclusion. Next slide, please. Thank you. So as we talked about, there are really three pillars. One is raising alerts through AIML, citizen authorities. Second is smart workflow to validate the alerts and evidence collection and escalation. Third is analytics to ensure the alerts are acted upon and the right progress is made in the right time. Next slide, please. So what we do, just to talk a bit about the AI ML work that is going on, that we do. The first step is we download the SkySat data on a monthly basis, auto rectification, all those things happen. Then the imagery is passed through a AI algorithm through it's a semantic segmentation algorithm that basically it goes through, and it classifies the imagery on single classes into buildings, greenery, fallow, roads, etc. Then the system looks at the temporal change in imagery. It looks at last 1, 2, 3, 4 months imagery and looks at temporal change in the classification to detect where a new building has come up. So imagine, if you will, in the current month imagery, a certain area is classified as a building. It looks at the last 1 month, 2 month, 3 month imagery to see if that place actually had a building or not, or if that place had a building of the same size or not. So based on that analysis, system will basically say, hey, here's basically where a new building has come up. And as Partha has shared earlier, not all the imagery will be true ortho, right? Sometimes there could be a small angle to it. So there is some post-processing things the system does automatically to ensure that all the shifts or kind of angles can be taken care of and doesn't raise any false alerts. But net is, once it basically goes through the algorithm and compares the temporal imagery, it identifies where a new building have come up, and then basically sends alerts to the official for validation, right? So typically it takes us about, from the point of receiving the imagery, it takes us about 8 to 10 hours before we raise the alerts and send back to the department officials from a further validation and action perspective, right? Next slide, please. Moving on. So this is an example of an imagery where, if you can see, on the right imagery is the April 2020 imagery, left is March 2020 imagery. There's a new blue shed that has come up. System basically classifies that shed as a building, right? And since the same area does not have a shed before, it basically automatically identifies that there is a new structure that has come up, and it actually checks with the permissions system also to see if there's a valid thing or not before it sends it out for a validation purposes. Moving on. So we also felt, the department also felt, engaging citizen is very important in the process, right? Because without their help, right, it becomes difficult, right, to ensure that system is sustainable and the process is sustainable over a long period of time, right? So in addition to the satellite imagery and AI, we have basically given a simple mobile app to all the citizens of Bhubaneshwar, where they can download from either App Store or Play Store, and they can use their phone number to log in using OTP. And if they see an unauthorized change which they feel should not have happened, they can just go to the location, take a picture, take the video, and submit the alert, right? And this system is meant to track unauthorized changes in government lands, right? So what we also do is we look at the geotag location of the citizen, their bearing, their heading, so on, compass integration, so that we know the citizen actually is reporting an alert in the government land, not in the private land, right? So, and once he reports alert, a SMS goes to him right away saying that we received the alert and we're acting on it, and then he can log into the same mobile app to see the status of the alert he has reported and see where at what part of the process the current alert is in. Okay, next please. Moving on. So once the citizen or the AIML supports or presents alert, the first step is, once it's triaged, the first step is all these alerts are sent to the concerned ward officers based on the jurisdiction, right? And the purpose of this thing is we want to make sure the authorities actually validate that this is a valid alert, and also tell us if the alert is a permissible activity or is in fact an encroachment. Sometimes what may happen is there may be a change that may be happening, but the ward officer may decide it's a permissible change because the same department building a new building, like right, or a shed right next to its building, right? So the ward officer has an authority to say this alert is changes happened, but is a valid change. Or he can say this a alert has happened and is an invalid change and has to be acted upon, right? So basically he reports the status of the alert in saying is it a valid change or is it invalid change. And if it is an invalid change, next slide please. So there is a very good structured SOP, standard operating procedure department has laid out in terms of how once an alert is raised, what each person in the chain of command needs to do to either say this is a valid alert or this is invalid alert. If it's a valid alert, how does it actually get re-verified, legal verification done, check the legal sanctity and validity, collect the evidence, and finally remove the encroachment. So all this process is laid out, and also for each step of the way, there is a well-defined SLA. How many days can a ward officer keep the alert with him? It's 2 days, maximum 2 days. He has to dispose of the alert from his mobile, and it goes to zonal DC for its further validation, goes to legal verification, so on and so forth, so that alerts can be quickly triaged and acted upon, so that a valid alert can get resolved in the quickest way possible. Right? Next slide, please.
Okay, so now we will have the third poll question. Can we launch the poll? So what is the most effective way to harness high resolution, high frequency satellite imagery for change monitoring? Is it the conventional visual change monitoring or using some manual method using remote sensing and GIS software, or should it be completely automated AI ML based, or should it be AI ML combined with manual QA and QC? So while we get the results from our audience, Partho, you have very vast experience in remote sensing and GIS domain. Which option would you go with?
Yeah, Pritesh, actually, in my opinion, uh, I'll go with the AIML with QA/QC. Because when users have the high frequency imagery, that means early change detection is very critical to them. And AIML is the platform which can help rapid automatic change detection. And as it is automatic, so that's why if we go for the QA and QC, so we can validate the result also. So that's why AIML with QA/QC will good in my opinion. Pritesh.
Okay, thank you, Partho. Can we have the poll results, please? Likewise, Partho, I think 85% of our audience also feel that it should be AIML with QA and QC. Thank you. Let's move on and over to you, Prasad.
Yep, thank you, Pradesh. So once the ward officer has collected the evidence and submitted evidence, there's a dashboard supplied or provided to all the users. So there's a user-specific dashboard. A ward officer can log in and see only the data concerned his ward. A zone officer can log in, see the data only regarding his zone, and how the various ward officers are performing underneath that zone, right? And the apex body can see the data of the entire Bhubaneshwar area and see who's performing well, who's not performing well. The purpose of that dashboard is, one, to give you a sense of how many alerts came in from what source, how many alerts came in from satellite source, citizen source, department source, and how many alerts are in what status of resolution, right? Are they still in the identified stage, are they in the validated stage, or are they in the resolved? What is the status of alerts by ward? Who's actually performing well, who actually needs to pick up their performance? How many alerts are with which officer to take further action, and how many days are they holding on to those alerts, so that we can ensure that the SLAs are compliant, and which wards are having the most unauthorized changes, right? So these dashboards are provided so that the ward officer, zone officer, and apex officer can see and act and ensure the performance is improved at their level. Next, please. as actually Partho said, the ideal way to do it is AI, ML plus QA/QC. So we actually developed a Geo Portal where it's used for QA/QC as a very quick QA/QC. That what officer can actually, before he goes to the field, he can look through all the alerts in the Geo Portal to see exactly what happened before, or what does the imagery look like right now for that alert, and what does the imagery look like for the last couple of months in that alert, right? And then go to the field to actually validate those things and collect the evidence for those things, right? And once he collects the evidence, all that gets consolidated in the Geo Portal. So it's one source of truth for that alert. What does the satellite images say? What does the evidence collection from the ward officer say? What's the evidence collection of the zone officer? Everything is in one place where this becomes evidence collection for them to actually file the further action on the alert. Next, please. And an iOS and Android mobile app is developed so that citizen can add alerts and get the status of what what is the status of the alerts that they have submitted. Department officials can add the alerts, validate the alerts, do the evidence collection for the alerts. Based on the user, they can also see the entire dashboard on the mobile app itself to understand the status and the various things, so that they don't have to go log into the web portal. Everything is on their mobile app itself. Next, please. So this system has been live now for roughly 3 months or so. So far, about 79 alerts have been raised by satellite imagery and AI. 5 of them have been raised by the citizen. I think this account has gone up in the last couple of days from 3 days back report. 3 have been raised by the department, totaling about 87 alerts. The key is already 11 of those alerts have been resolved, right? So as Mr. Malik has pointed out, each acre of land is worth about $2.5 million. So just these 11 alerts could easily add up to a value of more than $10 or $10 million plus of value. So this actually pays for the project 50 times over in less than 2 months. So the ROI of this system like this is fairly compelling, right? For a city like Bhubaneshwar, right? Next, please. Yeah, next, please. So we at Vasa Labs, we are a technology provider for this solution. We develop the AI, ML algorithms, we develop the mobile app, we develop the Geo Portal and all the analytics for this solution, right? We are a company that primarily focus on providing last mile visibility solutions through satellite, drone, IoT, crowdsourced data, and provide decision support systems on top of that, right? So geospatial decision support systems is primarily our focus area, and we work in the field primarily in the fields of water, agriculture, urban, mining, forestry. So anything land resource, natural resource management, smart cities is kind of the areas where we primarily focus on. About 180 people with office in India and US, right? So that's kind of and we use our core technology to develop this solution and deliver a compelling AI-based solution on top of SkySat imagery, and then all the other related technologies for mobile and geospatial data, so that the customer gets a overall kind of full solution, an ERP type solution to resolve the land use changes in the urban areas. Yeah, Pratish, I'll hand over back to you.
Yeah, thank you, Prasad, for an interesting session. We have come to the end of today's presentation, and now I'm opening it up for our question and answer. We have a number of questions. Let me go one by one. Here is the first question. What spatial and temporal resolution SkySat offers? Okay, Partho, can you take this up?
Yeah, sure, Pritish. Yeah, spatial resolution in SkySat, we offer ortho-rectified SkySat imagery in 50 centimeter spatial pixel size. Our panchromatic, our multispectral, as well as PanSert, all PanSurf, all ortho-rectified are available with 50 centimeter spatial resolution. And in temporal resolution or revisit, we offer sub-daily, daily, weekly monitoring. This is up as per the user's demand and as per the feasibility study. So that's our spatial and temporal resolution. Pritish.
Okay, thanks, Partha. Okay, now let me go to the second one. Which specific AI ML algorithm is being used to detect monthly land use changes? Prasad, can you take this up?
Yeah, Pradesh, thank you. Yeah. So, Pradesh, we are actually a Google Launchpad partner, right? We are one of the 10 companies selected by Google to work with on AI and ML. So we, for this specific project, we use architecture called TensorFlow convoluted neural network with a unit architecture, right? So that we
Okay,
can do a semantic segmentation of the image to identify the classes. Okay.
okay. Thank you, Prasad. Then the next question is, at what frequency SkySat image is acquired over Bhubaneshwar area of interest? And how fast are change alerts delivered? Mm, Mahesh, would you like to take this question?
Yeah, Pradesh, I'll take this. Here in the Bluish project, the government of Odisha, actually, they have gone for a monthly frequency for the entire city of Bhubaneshwar. And this Bhubaneshwar municipal area is about 250 square kilometers and is captured in 8 scenes by the SkySat satellites. Okay. And all these imageries for every month, they are captured in the first 10 to 15 days. So that means for the month of July, it's actually captured in the first 10 days of July. Okay. And once the data is delivered to ORSAC, they have a small team under the guidance of Dr. Mishra and Dr. Parida. They process these 8 scenes, and these processed imagery go through the AIML based algorithms built by Vassar team to detect and publish the change alerts. And this entire cycle typically takes somewhere between 24 to 36 hours from the time of delivery of data.
Okay, so in the first 2 weeks, they are kind of ready with all the change detection and alert process, right?
Yes, you're right, Pratish.
Okay, thank you, Mahesh. Let's go to the next question. It's about, can we access planet imagery directly in industry standard GIS software products? The answer is yes, but I would like Partho to elaborate on this. Partho, can you answer this, please?
Yeah, Pritish. Yes, standard GIS software directly we can GIS software or image processing software can accept our product directly. We support open platform, so we have a plugins for QGIS. So once the user install the QGIS plugins, and if they have the subscription of the Planet, they can get access to Planet data directly in the QGIS platform. No need to download, directly they can open the data in the QGIS platform and they can go for the GIS. And at the same time, similar kind of plugins is also available with the ESRI. So in the ESRI, we can also use that same. At the same time, our data, we have a very strong API. Using the API, we can access the WMTS or XYZ tile service in the GIS platform or any OGC compliant GIS platform, maybe desktop GIS or maybe web GIS. So that way we can use. And at the same time, our data is available in GeoTIFF. So definitely GeoTIFF you can open in any GIS, standard GIS platform. Pritish.
Okay, yeah, so that means we support both the commercial geospatial products, open source geospatial products like QGIS, as well as we adhere to the OGC standards.
Exactly.
Thanks,
Exactly.
Partho. Thanks, Partho. Let's go to the next question. Apart from SkySat imagery, what other geospatial data sets are used in the Bluish application? I think it can be best answered by Prasad because they have been implementing this solution. Prasad, would you like to take
Yeah,
this up?
sure, Pradesh. Yeah. So, as you know, Pradesh, the goal of the project is to identify changes in government lands, right? So once we identify where the buildings are coming up, the first thing we typically do is we overlap those classification with government parcel data to see if the changes are actually happening in government lands before raising alert. Okay, and then we look at the ward and zone shape files on top of that to see which ward officer and which zone officers should alerts be triaged to, right? So one of the common questions I keep getting, Pratish, regarding Blueist type project is, how do you know if the building coming up is legal or illegal? That's one of the other questions I keep getting along with this one. So typically what we do in other projects is there's also, as you know, there's a building registration system or a plan permission system that basically most urban bodies have. So we actually integrate with those systems also to see if the change that is coming up is actually legal or not, right? In addition to doing just the AIML as well. Okay.
Okay. Yeah, I hope that answers the question. Thank you, Prasad. We have many questions from our audience, but I don't think it is possible to go through all of them due to time constraint. However, we will reply to your queries through email over next few days. So with this, I would like to close this session today. And before concluding, I would like to thank Mr. PK Malik for taking out time from his busy schedule and his entire team of eminent scientists at Orissa Space Application Center for believing in our technology and architecting such a wonderful application called Blueist. A big thanks to Prasad, Mahesh Reddy, and Partha Ghosh for an interesting session today. And finally, thanks to our audience for their participation in this webinar. We treasure your contributions and time with us and hope you have come away with some constructive ideas around the technology and use case we presented today. So thank you once again. Take good care of yourself and your family. Stay safe and we'll see you soon.